In this session, I'm going to introduce you to the idea of a cross-tabulation. And we're also going to look at chi-square, which is the statistical test that's appropriate when you are analyzing nominal data within a crosstab. So what is a cross-tabulation? Crosstabs are actually one of the most common ways of displaying data in marketing research, and therefore also one of the most common ways to analyze data. Essentially what you're doing is you're looking simultaneously at two or more variables, and what you're trying to usually do is understand if the response to one variable depends on the response to another variable. And I'll show you an example in a second here with that. So with crosstabs you can actually report data that is interval, ratio, nominal, and so forth. You're not limited to nominal data. But the chi-square is a test specifically for nominal data. So I'm going to focus on an example of crosstabs where both variables are nominal, and we use the chi-square to actually perform our statistical test. So here's the example. Thinking about the rent survey data that we've been looking at so far. One of the variables is this choice variable. Would you choose to live in the same housing situation as before, the same condo, apartment, and so forth? Yes or no? And what we found was that 54 of our respondents said yes they would, 10 said no they would not, for a total of 64 respondents. Or another way of looking at those numbers instead of the raw data would be look at percentage and said they would, and 16% said they would not. So let's introduce a second variable here, gender. We had obviously men and women participate in our study, and it just so happened that 24 of our participants were men and 40 were women, or in percentage terms 38% of our respondents were male and 62% were female. So here's the question. We know that 84% of our respondents said yes, they would choose to live in the same place again, but did people's responses vary depending on whether they were male or female? That's the research question. So how could we really think about this? Well, what would happen if there was no relationship between choice and gender? In other words, if these variables were totally unrelated and choice had nothing to do with whether or not you were male or female, what would we expect then? And it all comes down to these proportions, percentages. What you might expect if there was no relationship between choice and gender is that if overall 84% of your respondents said yes, then you would also expect logically that 84% of your 24 men would also say yes. If you do the math on that, just 0.84 times 24, you get 20.2. Now obviously we don't have fractions of people, so you could round these numbers. But in proportional terms, that's what would be expected. And then you would expect the balance of our men to say no. 16% or 0.16 times 24 would give you 3.8. Similarly, if there was no relationship between choice and gender, we would expect 84% of our 40 women to say yes. So 84% or 0.84 times 40 would give us 33.6. And 16% of our women would say no. 0.16 times 40 would give us 6.4. So these are the expected values if there were no relationship between choice and gender. And essentially what we've done is we've held this proportion of 84 to 16 constant, both within our female respondents as well as within our male respondents. So what did we actually find in the survey? If these are the expected values, what were the observed or actual values? Well, for men, 18 said yes they would, and 6 said no. For women, 36 said yes, and 4 said no. So do these blue numbers, the actual observed, look materially different than the expected values? Well, just eyeballing it, it's kind of hard to tell. But there is a little bit of a clue here. Notice that 6 of the men said no. Only 4 of the women said no. What's interesting is that more men said no than women when there are actually fewer men in the sample. So it looks like men were disproportionately more likely to say no than women, but is that statistically significant? And that's where the chi-square comes into play. So the chi-square is the appropriate statistical test to use when we have frequency distributions, when we're looking at two or more nominally scaled variables. In this case, we're looking at two variables, so this is a bivariate analysis. So let's go ahead and look at the specific example that we just explained within SPSS and see what we find. So to do this analysis, I'm going to use Analyze, Descriptive Statistics, and crosstabs. Now, the first thing that I want to do is just show you what the expected and observed numbers would look like. So I need to pick my variables. Gender I'm going to put under columns. You don't have to do that, but I tend to like to put demographic variables under columns. It just makes more sense to me. Choice, that's going to be my rows. For now I'm not going to worry about statistics, so I'll uncheck that. In cells, I want to see both the observed or actual and the expected. The expected are the values that we would expect to see if there were no relationship between the variables. So here's what we find. These numbers should look familiar. The 20.3, the 33.8, 3.8, and 6.3. Those are the expected counts calculated using the proportions that we talked about before. 54 to 10. Alright, or in percentage terms, it was 84 to 16. And here are the actual count variables, or data right here, 18, 36, 6, and 4. So now we see what the data look like, the expected versus the observed, and the question is, are they statistically different? So this time we're going to go back in, run the crosstab. For cells, all I want to see now are the observed. And importantly, this time I want to pick my statistic, the chi-square. So we're going to get a few different statistics here, but I just want you to focus on the Pearson chi-square. So here's our table. Once again, this time it's a little cleaner. It just shows us the actual or observed counts within each of the 4 cells. And here's where we're going to look for an answer to the question of whether or not the difference between the expected and observed is statistically significant, the Pearson chi-square. Here's our chi value. You would look that up in a table, and this is actually our p-value. So here's where we're going to focus. The p-value is 0.11. That does not meet our threshold even for marginal significance. So we can say that the data give us a p-result that is not significant, meaning that there is no statistically significant difference, in this case between the expected and observed frequency counts.